Hello, this is Mrs. Pullen for Algebra 2. In this video, I'm going to go over the second half of the 7.05 lesson on the unit circles. And the focus of this half of the lesson is to find the exact trig values of special angles. In addition, not just the 30, 45, 60 that we developed in class. So the first half of the class, we developed the special angle chart, and though it's great to know the rationale for how the chart was created, the bottom line is you really do need to memorize these charts accurately and fast. And so let me first go over that. So you need to make sure to set up the chart so the column headings are 30, 45, 60 in that order, and their degree symbols. And the row headings should be sine, cosine, and the last row tan. And that's because, if you think about it, sine is y, cosine you should be thinking x, and tan is y over x. And as a synopsis or summary of what we did today, I showed you a quick way of remembering it. The first two rows are over 2. And if we look at sine, it's 1/2, then it's rad 2 over 2, and then rad 3 over 2. And cosine goes in the opposite direction. Tan is sine over cosine, so the 1 tan of 45 degrees is fairly easy to remember because anything divided by itself, remember y over x is 1. And for tan, the 30-degree angle and the 60-degree angle both have rad 3, but with the one with the 30 degrees is divided by 3. To get the reciprocal chart, remember, cosecant is 1 over sine, or the reciprocal of sine, so it's 1 over y. And so you can go ahead and just flip all of these. So this is 2, and cosecant of 45 would be 2 over rad 2. And if you rationalize, you get 2 rad 2 over 2, which is just rad 2. And then cosecant of 60 would be 2 over rad 3. And again, you would need to rationalize. So that would be 2 rad 3 over 3. Secant is the reciprocal of cosine. So notice it's in the opposite order of sine. So you just have to reverse the cosecant theta to get your answer. So that's easy enough. And finally, cotangent is the reciprocal of tan. So instead of being y over x, it's x over y, and we can just take the reciprocal. So rad 3 over 3 becomes 3 over rad 3. And then again, you rationalize, and you get 3 rad 3 over 3, which is just rad 3. And the reciprocal of 1 is 1. And now we want to take the reciprocal of rad 3, so that's 1 over rad 3. And when you rationalize, you get rad 3 over 3. Notice that's just like the opposite of the tan graph. So again, you really need to practice this and commit it to memory. So now let me do a more detailed explanation of how to find the exact value of sine of 135. So the first thing you need to do is draw the angle in standard position. So here's my initial side of the x-axis, and what quadrant is 135 in? Sine of 135 is in quadrant 2. And so you graph the terminal side in quadrant 2, and it connects to the circle at that point, and we're going to call that point x comma y. And then we're going to draw a perpendicular line down and form that right triangle. So this angle here is 135. Now, when you're in quadrant 2, the point really is not xy, it's really negative x comma y. Now, sine, we think of y, and we notice that y is positive here. If we were dealing with cosine, the function would end up being negative. So, but we're dealing with sine, and so we know that the function is going to end up with a positive value. The other way you could have done this is you could have done that little chart all students take calculus, and when you're in quadrant 2, only sine is positive. It's whichever way you want to think about it. The function that we're dealing with is sine, and we need the reference angle. So how do we get the reference angle when you're in quadrant 2? Well, what is the reference angle? The reference angle is the angle formed by the closest portion of the x-axis and the terminal side of the angle. So in this case, it's this angle, and what is that value of this angle? So if we see we have a half a circle on that top, like if you could cover up that bottom half, and a half a circle is 180. If I subtract the 135 from it, I get the reference angle of 45 degrees. So we went 180 minus 45. You could have also got that by memorizing the chart. So for those of you who are uncomfortable just visually looking at it, if you're in quadrant 1, the reference angle is equal to the angle. If you're in quadrant 2, the reference angle is equal to 180 minus the angle. If you're in quadrant 3, to get the reference angle, it's the angle minus 180. And if you're in quadrant 4, to get the reference angle, it's 360 minus the angle. So I tend to just visually look at it, but if that doesn't work for you, just memorize the chart. In any case, what we ended up doing is we simplified sine of 135. So it's the same thing as positive sine of 45. And then you would look at the chart that we developed, and sine of 45 was rad 2 over 2. Or positive rad 2 over 2, and that's the answer. Now, what is sine of 135? It's a ratio. When you're going ahead and you're on the first day and you were given a right triangle and you were looking at opposite over hypotenuse, you were finding a ratio. So rad 2 over 2 is just a ratio of the sides. So how does that work? Remember, we formed this right triangle on the inside. So let me just switch to maybe, I want a different color. Yeah. I just want a regular black color, okay? Remember that we form this right triangle based on the reference angle, okay? And the radius of our unit circle is 1. And the sine of 45 is going to be this vertical side over here, which turned out to be rad 2 over 2. And this horizontal side is really the cosine of the angle. That turns out to be negative rad 2 over 2, because you're looking at the ratio of the sides. So sine of 45 is opposite over hypotenuse, so that's where the red 2 came from. And the cosine, we're not asking for it in this case, would be negative red 2 over 2, because we based it on this angle and this reference angle that we created to form this right triangle. Okay, let's do another example. We want to do cosine of 210. And so the first thing you need to do is look for the quadrant the angle lies in. And 210 is located in quadrant 3. So here's my right angle. Here's my initial side. Here's my terminal side. And here's my angle of 210 degrees. And we're going to form a perpendicular line. We're going to do from this point, and that point really is negative x, negative y. And we're going to draw a line up to the x-axis, and we're forming this right triangle. And the radius of that right triangle is actually the hypotenuse. The radius of the circle, the unit circle is a radius of 1, is actually the hypotenuse of that right triangle. Okay, so we know our angle is in quadrant 3. And am I going to end up with a negative, or am I going to end up with a positive function? Well, we notice that in quadrant 3, both the x and y are negative. Therefore, both cosine and sine are going to be negative. So you're going to put a negative here. But if you didn't feel comfortable doing that, you could do all students take calculus, and when you're in quadrant 3, only tangent and the reciprocal function, cotangent, are positive. Therefore, cosine in that quadrant would be negative. The function we're dealing with is cosine, and we're going to calculate the reference angle. Now, the reference angle is this angle right here. It's formed from the terminal side and the closest portion of the x-axis. So how do I get that reference angle? I take 210 minus 180, and I get 30. So cosine of 210 degrees turns out to have the same value as negative, and I would circle this so you don't forget the sign, cosine of 30. And so this is going to be negative, and we go up and to our chart. And what is cosine of 30 degrees? It's rad 3 over 2. So our final answer is negative rad 3 over 2. And that little acronym sometimes helps students. So quadrant, S stands for whether it's a positive sign or a negative sign, the name of the function, and the reference angle. And again, if we were to label this, and I'll label it in purple, this side would be negative rad 3 over 2. Our hypotenuse is 1, and I didn't ask for sine. I could theoretically do Pythagorean theorem for it, but, that turns out would be negative 1/2, right? Because this is 30, so, and it's negative because the y values are negative, right? So the reference angle of 30 degrees for sine is 1/2. Okay, and let's do tan. So again, first thing we're going to do is find the quadrant that the angle lies in. I'm going to spell Cucifer right away. And 300 degrees is in quadrant 4, so the terminal side would be here. And you're making, here's my angle, 300 degrees. And you're going to draw a perpendicular line up to the x-axis. Here's my radius of 1. So in quadrant 4, my x values are positive and our y values are negative. I'm looking for the function of tan, and remember, tan is y over x. So in this case, it's negative y over x, and so tan is going to end up with a negative value. And if you feel uncomfortable with that, you could always do all students take calculus, right? And in quadrant 4, only cosine and its reciprocal secant is positive. The rest are negative. How do I get the reference angle? Well, again, the reference angle is formed by the closest portion of the x-axis and the terminal side. And so to get that, you would go 360 minus 300 and get 60 degrees. So this is negative tan of 60. And you would go to the chart, and when you look at the chart, tan of 60 is rad 3. So the final answer would be negative rad 3. Now so again, here's 60 degrees, here's 1. And we'll go more into detail again, like we're building upon our concepts, and you'll start seeing over the next 2 days more of how this gels together. I hope this video was helpful, and I'll see you tomorrow.